Hi kids, long time no hear. I hope everyone's well. I'm really sorry I owe you lots and lots of clips, but my iPad may not been playing nice lately, but I'm back. So fingers crossed it's going to work from now on. So I'm going to start with your straight line graphs pack, past paper question pack. And I'm going to start with question number 10. It's a 5-mark question. I tried it non-calculator. I haven't really checked what paper it's from, to be perfectly honest, but it's perfectly doable without a calculator. So let's make a start. So we've got 3 points. We know the coordinates of A and the coordinates of B, but we don't know the Y coordinate of point C, so we're going to call it K. And these are the vertices of a right angle triangle ABC. And we've got the angle ABC is the right triangle. So from this information, we can draw ourselves a little graph, and I'm going to do that here. It doesn't have to be exact. You don't have to plot it on any axis. I'm just doing just a normal right angle triangle, very wobbly. And it says that ABC is the right angle. So this means the right angle is here at B. And I don't know, I'm going to put A here. Maybe it's useful to write the coordinates here as well. So A is 2, 1, B is 6, 5, and this is C, and this is 4K. So I don't know the K. It says find an equation of the line that passes through A and C. So it's asking for an equation of this line that I'm highlighting in yellow now. And it wants me to give my answer in the form AY plus BX plus C, where A, B, and C are integers. So this is interesting. We're going to have to do some rearranging when we get there. But a lot of work for a 5-mark question. So first thing I need to do, you always know for a 5-mark question, you're not just going to get to the answer. You're going to have to do some work. So I don't have enough information on BC to do anything yet. So I'm going to start with AB because I've got these 2 points. I've got point A and point B. So I'm just going to start by doing the gradient of line AB. So I'm saying that M, so the gradient of AB. And you remember that's change in Y over change in X. And I'm going to subtract the Y coordinates. So I'm going to start with point B. So I'm going to say 5 minus 1 over 6, which is the X coordinate of point B, take away minus 2, which is the X coordinate of point A. So I'm just applying the formula for gradient, which is y1 minus y2 over x1 minus x2. So it doesn't matter what coordinates you use as long as you use them in the same order. So let me calculate here. 5 take away 1 is 4. 6 minus minus 2 is positive 8. So the gradient simplified of this line AB is a half. Now I know that the lines AB and BC are perpendicular. So this tells me, therefore, the gradient of line BC. So I'm trying to get closer to the one I'm interested to, AC. So the gradient of BC is equal to minus 2. Because the gradient of AB and the gradient of, fanciful, the gradient of BC are negative reciprocals. So when you multiply together, they give you minus 1. So that's how I know that the gradient of BC is minus 2. I'm going to work out the full equation of the line BC now. So this one here. Because I've got a point on the line, which is B, and I've also got the gradient of the line. So I'm using point B. So I like to make a list of my X, which is 6. That's the X coordinate of point B. Y, which is the Y coordinate of point B, and that's 5. And M, which is minus 2 for this line BC. So the equation of BC is equal to, you guys hopefully know that I'm using y equals to mx plus c, and I'm substituting in this equation. So instead of y, I say 5. Let me take this equal away because it's going to mess up my calculation. So y is 5, x is 6, m is minus 6, minus 2 even. God, I've lost my touch, sorry kids. So times minus 2, and then plus c. So I've substituted in y equals to mx plus c. So from there I've got that 5 equals to minus 12 plus c. So this means c is equal to positive 17. So the equation of BC is y equals to minus 2x, which is the gradient we worked out here, and then add 17, which is the intercept we worked out here. So now I know the equation of the line BC. So I know the equation of this line here. My lines are really shaky today. I can work out this k. So I can work out that particular y coordinate. So I know that for point C, x is equal to 4. And again, in my trusty y equals to mx plus c here, I'm going to substitute. So this equation is telling me that y equals to minus 2 times the x value, which is 4, and then plus c, which is 17. So I've already got it in the equation. I'm telling you, I'm losing my touch. I have to do these more often. So y equals minus 2 times 4 is minus 8 plus 17. I'm getting that's a positive 9. I can't trust my own calculations. Yeah, definitely positive 9. So this means the y coordinate, this k that we're missing here, is 9. No longer a question mark, is 9. Defo. All right, so we still have to work out the equation of line AC. We haven't even started on that, but we've got 2 points on the line. So on this line AC, and I'm going to again use this formula, so the formula at the top for gradient, to work out the gradient of the line. So the gradient, so m of AC, is equal to, we take away the y coordinates, so I'm doing 9, I'm doing c minus a basically. So 9 minus 1 over the subtraction of the x coordinates, so difference of the x coordinates, so 4 take away minus 2. So 9 take away 1 is 8. 4 minus minus 2 is positive 6. If I simplify that, I get 4 over 3. And that's the same as 1 and 1/3 if we need it. I'm just leaving that there. And now we have to work out the intercept of line AC, so the y-intercept. So you can choose any point on the line you want. I'm going to choose point A. So I need an x and y, and I also need the m, which I've got here. So if I choose point A, then x is going to be minus 2, y is equal to 1, and m is equal to 4 over 3. And I substitute this into y equals to mx plus c to find out the intercept. So y equals to 1. So I'm going 1 equals to minus 2 times 4 over 3. Add c. Great, fantabulous. So this minus 2 times 4 over 3 simplifies into 8 over 3. Minus 8 over 3. So c is equal to 1 plus, because I'm taking it to the other side, 8 over 3. That's the same as saying 1 plus 2 and 2 over 3. So that's basically 3 and 2/3. So hopefully you've been following this, converting fraction into mixed number to make addition easier. So now I've got all I need for my equation. So the equation of AC is y equals, so I'm doing it in the usual way first, and then I see what I can move around to bring it in the form they want me to have here. So y is equal to the m, so the gradient is 4 over 3 x plus 3 and 2/3. I might write that as an improper fraction. So I'm going to write it as 11 over 3. But it doesn't really look like what they want me to have. You see it says a, b, and c are integers. I don't have integers. It's not rearranged the way they want it. But to get rid of this fraction, I noticed that both of these fractions are divided by 3. So I'm going to multiply everything by 3. When I mean everything, I say everything, every single term of this equation by the same thing, so by 3. So y times 3 is 3y. 4 over 3x times 3 is 4x. And then 11 over 3 times 3 is 11. So now I'm nearly there. All I have to do is take this 4x across, and I'm going to have to take away 4x from both sides. So this is going to give me the final answer, which is 3y minus 4x equals to 11. And there you go. I'm going to try to do a couple more. If not today, hopefully by tomorrow, I'm going to be able to do more for you guys. Okay, so see you shortly. Bye-bye.